Okay, in this video we're going to take a quick look at compression using a practical example. So a compressor is a dynamics processor that's most commonly used for evening out the volume of a sound, and that's exactly what we're going to use it for here. So we've got this effects sweep here. It sounds like this. So you can see it's also got an auto filter on there, and that's just letting the high frequencies through, backs off a little bit, and then goes for the final push to the end of the sound. Now, in letting more frequencies through, it's also going to be boosting the volume as well. And you can see from the waveform of this sound that it's already increasing in volume as we get towards the climax of the sweep. And there's this slight kind of bump at the beginning as well. So when you're mixing a sound like this, it's quite usual to make sure that the end of the sound is sitting perfectly, because you don't want it to get too loud and peak on the master out. It needs to sit just perfectly with the mix. But the downside of that can be that with a long FX sweep, certainly one that has a large difference in volume between the start of the sound and the end of the sound, the beginning of the sound can go missing a little bit. Now, it's not so obvious here just using a drum loop, but if there were pads, leads, vocals, all kinds of other sounds going on, it may be that the beginning of that sound would very much be missing, and you might want to be able to hear it. So what we can do is use a compressor to even out the volume of this sound. So the compressor gradually kicks in as the sound gets louder, turning it down and making sure that it's much more flat along the length of the sound. And the end result here is that if we've turned the end of the sound down with the compressor by compression, then using the output fader of the compressor, we can actually turn the signal back up to where we would want that loud part to be. And in doing so, the quiet part will get turned up as well. So I've already set this up to a volume that I'm happy with on the output fader here. So let's turn the compressor on. And I'm just going to turn the makeup gain off because I find it quite inaccurate to work with this. Basically, as you turn the threshold down or boost the ratio, so the compressor in the background turns the signal up, and that's irrespective of whether any compression is happening or not. So it can actually be a little bit confusing. Now, let's have a quick listen to the sound again in isolation. And I'm just going to look here on this graph, which measures output here via input here. So you can see probably from around -12 upwards, close to 0, is the part where the sound's really pushing for volume. Now, I don't want to clamp down on the volume in its entirety. It's still important to have some of that working with the filter to give this sound some dynamic, but I do want to even it out a bit. So let's go for around -6 on the gain reduction meter here. So the first thing I'm going to do is set the ratio to something fairly modest. Let's start with a ratio of 4 to 1. So what this is essentially saying is that for every 4 decibels the signal goes over our threshold setting, the compressor will let through 1 dB. So that's quite a gentle setting, and I'm really aiming to have some gentle compression on here that's quite transparent. And you can see if we zoom in on the waveform that there are these various spikes of volume. I don't want to crush them. I don't want to change them in any particular way. I'm happy for the overall character of the sound to stay the same. I just want to respond to the average volume. And in doing that, we need to set the envelope to RMS. When it's set to peak, it will be responding immediately to those little spikes and volume peaks. It'll be looking out for them. In the RMS mode or opto mode, it's far more transparent and relaxed compression. And likewise, we'll do the same with the attack. It's fairly obvious what the attack and release do here. So we'll just have them set to quite long settings, and then let's have a listen. And we'll aim for about -6 dB, which is obviously going to be at the end of this sound. So you can see from the gain reduction meter, we're pretty much there. I'm just going to tweak the threshold a tiny bit. And you can see if we pull the attack down, you can see this juddering. It's pumping up and down on the compressor, which we don't want. We want this nice, gentle reduction. So it's happening very smoothly there, and that could probably be even turned up some more, but that can be played with another time. The final thing to do here, just to make this even more natural, is to use the knee setting on the compressor. So Live has a variable knee, which is very handy, and what this is essentially doing is, let's set this to 8 dB. When the signal gets to a point that's 8 decibels before our threshold, the compressor is going to start to react. Now, it's not going to react with the full ratio amount. It starts much lower, probably starts from the smallest ratio possible at that exact point. So at 8 decibels before the threshold, the compressor starts to kick in, and it basically starts turning the ratio up gently like this. So we'd be perhaps at 1, and it starts turning it up gently. Then it's going to get to the threshold point, and it's still not going to be at the ratio that we've set. It will keep pushing until it gets to around 8 dB after the threshold. So when the signal is going over the threshold by around 8 dB, it will be at the full ratio of 4. So what it's essentially doing is progressively increasing the ratio around the threshold area, and that's just providing a much gentler compression. So the final thing to do is to A/B this to make sure that what we've actually done sounds good. So we know that we'd set the sweep to a volume that we wanted before we use the compressor, so we can just check. Again, I'm just going to have the loop set at the end of this, at the loudest part, and see what this was maxing at the time. Okay, so it's around -7. So let's set the compressor, which is obviously now reducing by around 6 dB. So we can turn the output up by about 6 dB as a starting point. And let's have a listen now to see where our output is peaking. So that's a bit too much. So there we go, that's pretty much perfect. So we're now at a position where we can have a listen to what we've done here just by turning the compressor on and off to A/B this sound. And obviously this is going to be most noticeable at the beginning of the sweep. So let's have a listen. We'll do it in context with the drum loop. So you can hear it's now much louder at the beginning of the sound, and we may want to add some kind of sidechain compression or something to this sound, and it will be much more obvious at the beginning. So let's just open the sidechain up. We'll have the input from our drum loop. So now what's happening is the drum loop is triggering the compressor, but the compressor is working on our FX sweep. But we only really want the kick drum in this case. So in order to do that, because we're dealing with a loop here, we can use this preview button to listen to the material that's coming into the compressor. And if we set this EQ, we can set exactly what the compressor's listening to in order to set the ducking. So let's look for a nice even pumping here. And now we're getting nice pumping sound. Obviously, it would be much better to have the kick on a separate channel, but we can use that to set up a nice kind of sidechain effect on this sound. So that's using the compressor to tame the dynamics of a long FX sweep. There are some downloads available on the website to subscribers. We'll also put this set up there so you can have a play around with it yourself. If you're not a subscriber, just go to www.quantizecourses.com, and on the right-hand side, there's a small box. If you pop your email in there, you'll receive the links to all the downloads. Hope you've enjoyed the video. Thanks very much.